The ground thermal design of heating buildings should consider not only the requirements of building energy efficiency, but also the difference of human health, comfort, and heating measures. In floor thermal design, the surface material with thickness of about 3 to 4 mm has the greatest impact on human thermal comfort and health. The apparent density, specific heat capacity, and thermal conductivity of the floor surface material are important parameters that determine the endothermic index of the ground thermal performance index. For example, wood floor and terrazzo floor, even if the surface temperature is the same, it is cooler on the terrazzo floor because the endothermic index of the two is different. The B value of the wood floor is 10.5. The B value of the terrazzo floor is 26.8, and the endothermic index, the larger it is, the more and faster it will absorb heat from the human foot. In most cases, the heat absorption index is approximately equal to the thermal permeability coefficient of the surface material. Therefore, the surface material with small thermal permeability coefficient should be selected for floor design. For buildings with low temperature hot water floor radiant heating, wood floor with kill should not be used. Pipes should be laid in dense materials with large thermal conductivity, and surface materials with large thermal diffusivity should be used. The bottom ground is a direct contact part between the building and the soil. The ground is divided into peripheral ground and non-peripheral ground. The peripheral ground refers to the ground within 2 meters from the inner surface of the external wall, and the other ground is non-peripheral ground. The thermal resistance of surrounding ground of public buildings in severe cold regions should not be less than 2, and that of non-surrounding ground should not be less than 1.8. Ground thermal resistance refers to the sum of the thermal resistance of the materials from the ground to the cushion layer and the heat exchange resistance of the ground upper surface. When the ground thermal resistance reaches the specified value, the buildings in severe cold regions often have the phenomena of frozen fate or the ground frost heating and buzzing. This is because the closer to the external wall, the larger surface temperature of the floor, and the greater the heat loss per unit area, within the range of 1 meter wide around the inner side of the external wall, the ground temperature difference can reach about 5 degrees. Therefore, it is necessary to do local thermal insulation treatment along the inner periphery of the bottom's external wall. Thermal conductivity is the most important and basic thermal-physical index of insulation materials. There are many factors affecting the thermal conductivity of materials, including density, humidity, porosity, working temperature, thickness, and so on, among which density and humidity have the greatest impact. The selection of thermal insulation materials should consider the function, structure, construction technology, material source, economic indicators, and other factors of the building, according to the thermal physical properties, strength, durability, fire resistance, and corrosion resistance of the material. The types of thermal insulation structures mainly include single thermal insulation layer, closed air interlayer, combination of thermal insulation and load barrier, and mixed type. The method of setting up a single insulation layer does not require the insulation layer to bear the load, and the selection is flexible and plate-shaped. Fibrous and granular materials can be used. The thickness of the air layer in the enclosure structure is preferably 4 to 5 cm, and the interlayer surface should adopt strong reflection material to reduce radiation heat dissipation. Hollow slabs, porous bricks, etc. can both bear load and keep heat with simple structure and convenient construction. When one method alone cannot meet the thermal insulation requirements, or when the economy and the technology are unreasonable, the mixed-type thermal insulation structure is mostly used, which has a complex structure and is mostly used in rooms with high thermal requirements, such as constant temperature rooms. When a single insulation layer is installed, the position of the insulation layer has a significant impact on the structure, room quality, cost, construction, and maintenance. The thermal insulation layer is called internal thermal insulation on the indoor side of the load-bearing layer, external thermal insulation on the outdoor side, and sandwich insulation in the middle of the two dense structural layers. Compared with internal insulation and sandwich insulation, external insulation has many advantages. 1. Protect the main structural part of the outwall or roof and reduce the fluctuation of temperature stress. 2. It is beneficial to the thermal stability of the structure and the room. 3. It is beneficial to prevent or reduce the condensation of water vapor inside the insulation layer. 4. Reduce the heat loss at the thermal bridge and prevent local condensation on the inner surface of the thermal bridge. 5. The renovation of old earth will not affect the residents. 6. Does not occupy indoor use area. However, in large-scale public buildings, the heat storage effect is not significant. The structure is more complicated than that of internal insulation, and there must be a protective layer. The requirements of the protective layer are higher than that of the internal surface layer of internal thermal insulation. The construction difficulty is greater than that of the internal insulation layer. When the roof waterproof layer is installed on the insulation layer, it is easy to age and cause internal condensation. The current engineering practice is, in extremely cold regions, sandwich insulation is used for external walls, and external insulation is used for roofs. In severe cold areas and cold areas, external insulation is used for external walls and roofs. In areas with hot summer and cold winter, residential buildings adopt internal thermal insulation, and public buildings adopt external thermal insulation. In areas with hot summer and warm winter, adopt a self-insulation system or internal insulation that combines thermal insulation and load bearing. In temperate areas, emphasis on seating and thermal insulation of transparent envelopes. Special buildings in any area, such as cold storage, use mixed heat preservation. When a roof with internal thermal insulation is used as a waterproof layer on top of the thermal insulation layer, the waterproof layer is exposed to the atmosphere, exposed to sunlight and alternately freeze thawed. This is very easy to age and damage, and it is easy to produce condensation inside. Therefore, the practice of laying the roof upside down was born, and the waterproof layer was laid under the insulation layer so that the waterproof layer was protected. However, the requirements for thermal insulation materials are higher, and a cover layer needs to be provided on the thermal insulation layer for protection. The covering layer can be made of large slab bricks, prefabricated slabs, pebbles, etc. You can investigate the current building thermal insulation materials and their practice, and also analyze the thermal insulation problems in school buildings so as to think about why the external insulation is damaged every year.